Hi everyone, warmly welcome to the Astro Week hosted by Astronomy INC under the Astrobiology and Paleontology Certifications Program. This is day 17 of this exciting lecture series for the South Asian region. Today we are going to discuss about the space, robotic, and AI computer vision. As we venture into this a critical topic, we are honored to introduce a distinguished guest speaker, Karishma Inamdar. Dear Karishma, warmly welcome to the Astronomy INC platform. Let me highlight a very brief intro about today's our guest speaker. Karishma is a robotics and the computer vision engineer who grew up in India and her master degree in space science in France and has been advanced in her career in United States. She is specialized in robotics and artificial intelligence with expertise in a computer vision and machine learning to design advanced methods for various autonomous systems on land, in air, underwater, and in the space. She began her journey at NASA Ames Research Center, where she contributed to the pioneering project in autonomous robotics. Since then, Karishma has worked on climbing robots, underwater submersibles, ice moon exploration, and the autonomous satellites technology. She also an analog expert, having accomplished missions with the NASA Johnson Space Center to support research for future lunar surface, operating in Artemis missions. Beyond the technical career, Karishma is deeply passionate about the space outreach and education. She founded the Next Space Generation, an initiative that inspires and guides students through the space camp, lectures, and mentoring, helping them understanding how robotics, AI, and interdisciplinary nature of space industry are driving to the future of space exploration. So today gonna be very exciting. With that being said, I would like to invite this young, talented, glorious scientist, Karishma Inamdar, to address Astronomy INC International Platform. Dear Karishma, now it's your time. You can get started.
Yeah, as Aravind, gave introduction. Today, I'm talking to you about space robotics through my work experience in AI and computer vision. So, hello everyone again. It's so glad to have this opportunity to present my work with you. And by the end of the lecture, I'm hoping to, inspire you to do whatever you like. It could be space robotics or other interdisciplinary aspects of the space. So before I start, I would like to give you a little bit introduction about me because I feel like it's important where you come from and how you have taken the journey. So I'm born and raised in India. I was born in a very small town. It's near Pune in the state of Maharashtra. It's called Baramati. And I finished my education there until, bachelor's in electronics and telecommunication. But when does this started? When does this started that I had a dream of becoming you can call it like space scientist or space roboticist. So in fact it's actually started back in 2003 in the month of February. By the time I was interested in space, but I did not know like what are the opportunities, how a small girl from from a small town can dream of going to space and like doing something bigger than herself. This incident was I was waking up in the morning and I saw in the news in the small CRT monitor, which you might probably not know by now because yeah, it doesn't exist anymore. But yeah, anyway, so I saw the news in the TV, and it was the news from USA, and people, like some team, were collecting like little bit of rocket parts, and they were showing like there was something re-entering the earth, and something has blown up in the like while it was re-entering the earth. And um, that incident was space shuttle Columbia disaster. I was witnessing that through the news, and as I read more about it, I got to know that there was an astronaut, Indian origin astronaut, sent by NASA uh, to this space shuttle program called Columbia, and she had died along with like seven other crew members, and that was deeply sad to see that, like to see that big loss for everyone, and like all of these amazing astronauts. But that day, I had someone to look up to, and I started dreaming of space. I started thinking that like if she can go to space, I can also go to space. And she has been my role model, inspiration throughout my journey. And since then, I started, like reading whatever I can find about space. So back then, like, like ChatGPT, Google wasn't, like as easily available as it is now. So I would, like go for like, like find books. Books are always good, by the way. Now also you should read books, not just rely on ChatGPT. So I would find books. My parents would take me to stargazing events in Pune. So they have this astronomy center called Ayuka. It's a very renowned center, and they also have like many space scientists always coming there and collaborating. So my parents would took if there's like any guest lecture from any space scientist, so they would took me to that guest lecture to have the exposure what it is to be a space scientist. So when the world, like when the parents in the world try to push girls towards like practical ambitions, my parents were feeding my wonders, and I'm really grateful for that. That they used to, like give me these exposures. But yeah, long story short, then I graduated from India in electronics and telecommunication engineering, and then I had a chance to go to France to study masters in space science. And I call this moment, this master's degree, as my launch pad, because that's where my dreams took off as a, like as establishing career in the space industry. From there, I had a chance to do internship. I got selected to do internship at NASA Ames Research Center here in California in United States. And rest of the things is history. I started my internship in 2015 and ended up working here. And I'll walk you through that journey. What are the projects I have worked on throughout this adventure? That I like to have interactive presentations. So before we go ahead with what are the exciting projects I have done, I would like to ask some of you, why do we explore space? Can someone tell me why do we explore space?
Dear students, now your time, and our guest speaker is asking some questions. And if you know some interesting answers, make sure to raise your hand. Yes, I noticed Reshma.
Yeah, please go ahead, Reshma.
To find opportunities for life beyond it.
Yes, that's very interesting answer. Yes. Prabodhi?
Yes, Tiveng, go ahead.
Sir, I think they are like to see there if there are new organisms or aliens.
Yes, that's a very good answer. Yeah. So as I was explaining, and you guys are so, like so right, because Yes, that's one of the reasons. So there are like many other reasons that why you would explore space, and like it's basically like driving scientific discovery, driving innovation. It helps us here on the Earth to solve so many problems, to do Earth observation, like to have communications and and the navigations, like we have been using Google Maps so easily nowadays. So there are many things, but one of the thing which boils down to human understanding is like human curiosity. We are very curious about exploring space, what it could be. And as you told me, that if there is any alien life there, like alien could be like in terms of the life form that we don't understand yet. And as far as we know, planet Earth is the only place where we have, like life form. So that's one of our, like core reasons that we, like we like to do, we like to explore space. Along with that, now I'd like to ask you, uh, why do we explore with robots? Can someone explain me why do we explore space with robots? Why not just humans? Yeah, Savin?
It's because that if we try to send humans to space, it's going to be really hard to get all of the food, water, and other resources needed to keep them alive for the long period of time that they might be up there.
Yes, amazing. What a brilliant answer. Yes, that's one of the main answer. How about Linaya? What did you had in your mind?
Because it could be very risky to send people, as like first of all the food problem is there, but as of other things with mechanics and stuff, it is very risky to send people.
Yes, yes. You guys are so correct. It's like I'm just here talking with you. You guys already know so much stuff about it. So yeah, one of the main thing is like we cannot risk sending humans because we don't know much about those environments, right? And that's why we try to explore with robots, because in these extreme environments robots are like our hands, our eyes, our ears, right? They go first and they try to like try to map the environment. How is the environment? What is the composition of the like whatever things exist there? Like it could be a soil, it could be a atmosphere, and it could be some another new world. So we try to send many robots through many forms. And I would like to give me a second. I would like to ask you here that what type of robots do you see? And you can just, yeah, you can just unmute and like tell me.
Yes, Savin, go ahead.
We can see like rovers, rockets, satellites, and other sorts of machines like that.
Yes, yes. So you, yeah, you named three correctly. One of the thing is also like this one is a lander, and this one is actually a Mars helicopter, which went with like Mars 2020. If you guys remember, that is also the form of the robot. So as we dive more deeper into it, I will talk you through about how these different robots works for the different purposes. So before going ahead, I would like to give you a little glimpse of the projects I have worked on, and we will talk a bit by bit as we go much more deeper into that. So as I told you, I started my career at NASA Ames Research Center. One of the project I worked there as an intern was a small submersible. And here I would like you to think like how you would use this small submersible for what purposes. I would like to extend your imagination, and I'll get back to you very soon asking that question. Another thing things I have worked is autonomous UAVs. It's also called unmanned aerial vehicle, and in the simpler terms, it's called drones, if you know about it. So I have worked on various research drones, commercial drones, and yeah, while I was doing this, I was actually, like thinking to get a PhD. And why I'm sharing this story, because the story is very important. Like, not everyone has the same path. Not everyone wants the same thing. So as you are developing your career, always see like what you like and what you want out of that, instead of just, like blindly following your role models or whoever, like people are there around you. So while I was doing this work, I wanted to do PhD, and so I left NASA to explore my options for PhD. And during that, I got a chance to work as a visiting computer vision researcher in one of the Japanese university. It's called Tohoku University, and they have this really nice lab called like Space Robotics Lab. And I had a chance there to work on climbing robots. Amazing project. It has like amazing team. I really liked that project. After that, I had a chance to visit as a computer vision researcher at Stanford University, and I worked there on like a couple of projects for like trajectory optimization. But while I was, at these universities and doing these projects, then I had a dialogue to myself, like, do I want to spend next 5 years doing the PhD and, like learning more about robots through computer vision angle, because I wanted to, like learn through computer vision angle. And at the end of these adventures, my answer was no, I don't want to do PhD. I want to continue working in the industry. So I decided to go back to the industry. That's where I joined this phenomenal company. It's called X Dynamics, that was based in Los Angeles. Um, I worked there on the commercial drones, and after that, like for almost like decade of experience in the robotics. Now I'm actually working on my own company. I have started a startup, and we'll talk about this. Yeah, as we go ahead. Uh, as we like talked about. The types of robots, like rovers, landers, drones, satellites, and even rockets are technically robots. Not the conventional rockets, but the rockets with, like autonomous landing. So like SpaceX Falcon 9, that can technically be considered uh, as a robot. Um, So now one of my interesting topic, it always inspires me, and I wish it will also inspire you. Who can tell me what are these things around the earth? You can just unmute and tell me. Who can identify what are these?
Yes, Liana, go ahead.
Other planets that are said to have water, as an icy surface.
Yes. So these are the icy moons in our solar system. So as you can see here, there is Enceladus and Titan. Those are Saturn's moon. Then Europa, Callisto, Ganymede. Those are Jupiter's moon. And Triton is the Neptune's moon. And all of the common thing they have is they have water there. These are icy moons. And as far as we know, where there is water, there is life. So these could be a really good potential candidates, like to go there and to explore like what is there, what kind of, like life form exists there. And that was my inspiration during one of the projects. It's called CubeSub, which is, I'll explain you in a bit what it means. So it's basically small submersibles. And so you remember I asked you a question about if I'll give you a small submersible, where would you go? how would you explore? Do you have any answers for that? How would you go and explore? Anyone?
Yes, Sami, go ahead.
We can use small submersibles to explore the 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 moons and planets that have water so that we can check if there's any microbial or any other living life forms on those planets or moons.
Yes, yes, that's so correct. Oh my God, you guys are so talented. You are already giving me answers, and you already know lots of stuff. So that was one of the inspiration. So when I started this project, it was in a concept design, and me along with like a few of our team members, we started thinking how we can make a submersible small enough that can easily be like carried on the rocket and like send it to any of these moons. Although before I talk about this, I have to go a little bit back, and I would have to tell you that right now sending a submersible is not possible at this moment, because we still have to go there. Like one of the candidate right now we are looking is Europa, and if you are updated about it, like we have sent a Europa Clipper mission to understand more about this icy moon. So the first step would be like to understand more. Then there is second step, like landing on the icy surface, because we haven't really landed on any icy surface yet. Then third would be how you gonna drill that icy moon, right? Because it's like hundreds of kilometers of icy crust, and the ocean under there is the ocean underneath it. So the third challenge is going to be how you gonna like drill that icy surface. And then the fourth step is sending this submersible to like to understand what kind of like life is there. So yeah, we were in that fourth phase. Of course we haven't done these three, but we were in that fourth phase of conceptually designing how it would look like if we can send a small submersible. So we came up with a thing called, it's called CubeSub. It's basically a form factor designed in the form factor of CubeSats. And if you guys know about CubeSats, cube satellites, it has like 10 centimeter by 10 centimeter form factor, and that is like a 1 unit, right? And like you can add as many units as you want based on your payload. So the same concept we carried for the CubeSat, that we added like in the moment we needed 2 units of payload. So here you are seeing like 2 units of payload um, CubeSub, and we added like bunch of sensors there to understand like water salinity, temperature, and bunch of like other stuff. And the way we design the submersible is like it had like very modular payloads, so you can easily like change the sensors or like change other modules and like take that to explore some other stuff based on your needs. And um, this can be also taken to like to explore our own ocean, because we don't know much about our own ocean. So that was very interesting project, fascinating like start of the career. After that, I had a chance to work on a couple of drone projects, like commercially, and the research project as well. So one of the research projects I worked on, so at NASA Ames, they have this project called UTM, Unmanned Traffic Management, and they are basically trying to see how you can integrate small drones into current aerospace system. So like how the communications would work, how the collision avoidance would work. There's like many aspects of it. And one of the project I was working on was under the like under the umbrella of this project. And this project was we were trying to build autonomous drone. And what does it mean is, so right now, like when you operate drone, there is always an operator most of the time. So what we are trying to build is like, if you want to send our drone beyond line of sight, how it would operate autonomously. And I started working in computer vision on this project, since this project. And one of the core algorithm I worked on is called SLAM. It's known as like simultaneous localization and mapping. In simpler term, what it means is, and I'll tell you more about it, what it means is, as you're walking through the environment, for example, like consider it's you're walking through the environment, you are constantly scanning the environment, and like building kind of mental map to navigate through environment. So like when you walk, oh, there's a table, okay, I need to avoid this table, go around the table, like, and then you walk, and then there is a door, okay, I need to go from the door. So your drone is basically building that map around you, and like try to navigate through the environment. And SLAM is one of very core algorithm of like heart of the autonomy. So like take any autonomy projects, and you will find SLAM in that. So that was that project. Later on, I worked on a commercial drone. These two drones are like the company I have worked on. It's called X Dynamics. And I was actually trying to build their next generation drones. I haven't built these drones. I was working on the next generation drones. And that drone was like, one of the goal was that drone, it needed to be a lightweight, like under 250 grams. And one of the challenge was how you can make this drone autonomous with this, like payload construction, payload restrictions. So yeah, I was working on how you can build this autonomously, and how you can have obstacle, specifically like obstacle avoidance algorithm in that drone. So these were like very fascinating projects. So as you might have noticed, I'm using word autonomous a lot. And I would like to give you a little bit of introduction. What does it mean by having autonomous robots? And there are actually many components than this about autonomous robots, but from the computer vision angle, I would like to, like give you a simplest definition. So these robots, they basically have sensors. So their sensors are like cameras, LiDAR, GPS, like IMU. And what they're trying to do is trying to take as much data as they can through these sensors. And they also have the perception system, where it's taking that sensor data and then processing to understand the environment. And the third main factor, which kind of says if it's autonomous, because it has its own decision making. You can also call artificial intelligence, which we'll talk about. Um, so it has its own decision making, and we are not intervening, like in those robots. They make their own decisions, they navigate through environment, etc., etc. So while talking about that, how do they make their own decisions? So that's where artificial intelligence comes in. And I'm sure you have been hearing this buzzword a lot lately in the form of everything. There has been, like many bots, like through ChatGPT and things like that. You have been hearing this. So I would like to talk about artificial intelligence based on two factors. One of the factor is like based on its functionality. What does it do? Like what functions it has? So one of the thing we talked about is like, like perception AI, so which is basically a computer vision, like how it's sensing the environment. Second is, like decision making AI. So in decision making, what it does is like it has its own path planning. So it will try to see how it will navigate through the environment. Like understand the priorities. If there is some obstacle, of course, it's going to avoid that obstacle. So it has lots of that decision making going on. And when you see obstacle, so that's where like action and control AI comes in, where it will sense it and then it will take a decision. I need to avoid this. So there's like many things going on inside that. And one of the other category is interaction AI. I think general public have been using interaction AI a lot, like through the form of ChatGPT. You interact with it, like you give some prompt, it gives you answer. So that's basically comes under large language models, they call LLMs. And yeah, all of the basics of that is natural language processing. And second thing, give me a second. Second thing of AI is based on the techniques. So how do you make these things possible? And one of the main thing, so usually I don't like to use term AI. It's too loose, but it's colloquial. Technically, you basically like call it machine learning. That's the proper word for it. So because it's basically machines, like learning things. So in machine learning, there are like many other things, but one of the main techniques are deep learning, where you are basically giving like lots of data, and your models just try to make correlations between that data, understand what's like what's the common thing, and like understand the patterns, and then make the decisions. So that's where like deep learning comes in. Reinforcement learning has been like really helpful in the robots too, because you have like some sort of like penalty based system. So when something is wrong, like you assign the score that, oh, this is not wrong, and then that's how it try to learn. It's basically how we teach, I don't know, how we teach kids, um, in terms of not in terms of penalty, but yeah, in terms of how you how you teach them about the surrounding environment. And one of the third thing, which not that many people knows about yet because it's just coming up, it's a physics-based machine learning, which is amazing because it's try to learn like fundamentals, like fundamental models of the physics, and also like the physical reality around you. So it will just like understand the things and make its own decisions, and it has many scientific applications. Slam. Give me a second. So as when I was talking about drones, if you remember, I told you about a SLAM algorithm. It's like simultaneous localization and mapping, which basically how robot navigates its environment. So for example, here you are seeing an image where robot is basically your car, and in the like in the top image you are seeing like car is going through the roads, and those green dots are actually the features that car is trying to understand, like what is around it. And in the bottom image you are seeing like it's kind of building its own map as it's going through, like there is a road, there's the buildings, and it also understand if it has revisited the things again. So this is very basic algorithm for autonomy, and yeah, that's how basically it works. I wanted to show you the video to have like more visuals, but there's like many things, many deep things going on here which I won't explain. Yeah, another thing I wanted to explain is object detection, because this has been very useful in many things. And the interesting fact is actually fact about computer vision. It's not at all new field. People think that yeah, it's new, but this has been going on since 1960s. So in one of the summer, MIT had this project called, hey, let's try to figure out if we can understand the objects, like in the picture. And it took us like only 70 years, 70 to 80 years to understand what going on in the objects. Like recently it has developed to this level. So in the image you are seeing that it's basically like image recognition. So it has ships, it has a dog, and it will try to understand, like, oh, there are ships, there are dogs. In the object detection, it tries to, like, understand it independently. It can also see like how many things are there. And then there is like semantic segmentation, where you basically understand in the broader strokes. So like this is the blob of the ship, and like in the background there is, for example, grass, or there is a sky. So it will understand in those blobs. And if you go more deeper into it, it's like instant segmentation. So it will try to understand if things are overlapping each other. If there is a crowd, how many people are there? Can they, like, distinguish every person? So it goes like much more deeper into this. Give me a second. And I would like to touch a little bit on autonomous satellites, because that's like very interesting next thing coming up. So right now our satellites are very conventional. We do, like telemetry, telecommand, and of course like everything we operate is from the ground stations. um, but like with the advances of machine learning, and like many other like relevant fields, there has been things in like navigation, orbit control. So like they will be able to fly by themselves, like making the like trajectory optimizations on the go. uh, there is like other things such as like fall detection. They will understand if something is going wrong, and they will like inform us as soon as they detect the things. And there is like many things in the payload operations, like from Earth observations to like to the navigation satellites, that we will be able to know what's going on. So this is the next frontier, which is just opening up. People have just started talking about it, and yeah, we'll go more ahead in that. Yeah, so usually I say that even though like I do robotics and lots of other stuff, on the weekends I always like to go in nature. I love hiking, backpacking, camping. I like painting in nature. And recently I have been taking these calligraphy classes, which is very beautiful form. It's like combination of Arabic and Chinese. And yeah, it's a my new art form that I'm working on it. It's always important to take some time for yourself, time to time, and recharge, like whatever you like to do, uh, apart from your work. So yeah, one of the important slide. So as I talk through, like my journey, but this talk isn't about me. It's about you. It's for you, because you are the next space generation. So I want to give, like a little bit advice, if I can, about, like how much your dedication and hard work matters. Always, like try to reason from the first principles. Your critical thinking really matters. Try to work like with the team, because all the projects you worked on, there's no like you cannot achieve this by yourself. There is always team behind it. So try to like learn those skills as early as you can. um, One of the important thing, all the people I have met until now, like astronauts, space scientists, engineers, all the people in the space industry, and most of the people I have met, one of the common thing they have is they are so smart, but they're so humble. So always be humble. Never brag about things, because there is always like another person who has done the best thing in the world. So always be humble, always be small. uh, Learn from your failures. As you see, like throughout my journey, I talked about like I wanted to do PhD, but then I didn't do PhD. So it's important to recognize, okay, it's fine. Like you have failed in one thing, but take take on that and take the lessons from it, and always start, like moving forward from those lessons. And the last and one of the important thing, less screen time. I always say that to students because um, yeah. And the last thing, if you have any questions, not right now, but like in future, feel free to like talk to Arvind, or like send me. You can shoot me email here, and I would always try my best to like to give you advice about it. And I had bonus slide which I'll tell later, but I would like to take your questions first.
Thank you very much, Karishma. How I know very informative and very inspiring talk to the our next space generation. Of course, they are the I feel like future. Dear students, now we are opening to the Q&A sessions over here. And if you have any further questions regarding the today's very interesting talk, make sure to raise your hand. And I believe, Karishma, I also have a few couple of questions. While I was talking with the many of Indian scientists, so what I noticed, like Kalpana Chawla make, I think, more inspirations and more motivations to the whole the nation. So even Siddharth also said like same thing, and today you also said the same name. And so like, what exactly the reason? Like after you seen such an incident, how you feel it?
Yeah, that's a very good question. And like, yeah, when I talk about this thing, sometimes people get confused. Like they're like, what? Like you saw a rocket, like the capsule blowing up in the space, and that's how you decided you want to be astronaut. Uh, like that feels like surreal in a way, but like it wasn't about like what went wrong, because of course, as I said, like we learn from the failures. Uh, but it's about what went into it, right? Like it was such a dedication, like the teamwork. And one of the main thing was, like, as I say, as I explained, like the Kalpana Chawla's journey. Like when I read about her, there were so many similarities in terms of, like, of course, like I'm not at all, like uh, even a smaller percentage closer to her. But like knowing that she is also Indian, she was born in India, like in the town, and then she was able to reach the stars. Like she was able to took off, like that journey. That kind of gave me inspiration. Like, hey, like I don't need to be just small and like be here and like like dream about just, I don't know, like the local things. And not to leave the place. So that, yeah, that had that had big uh, yeah, big impression on me. And I when actually I started my journey at NASA Ames, I met so many people that they worked with her, because coincidentally, like she also started her journey at NASA Ames. So that was just like so humbling experience for me, even though to go there to talk to people who has worked with her, and like they were telling me all sort of fabulous stories. And there is also a supercomputer at NASA Ames, which was, like which is named after her. So I went and to see that supercomputer. Recently, I went to NASA's Johnson Space Center, and which is, like we all know that it's known for, like astronaut training and like, yeah, all the astronaut operations. And I was part of this mission. And in that also, like they had a wall with, like the disasters happened, and like one of the wall was like the Columbia wall, and it had, like Kalpana Chawla there. And like just walking in that room, it was so humbling. And to see like, hey, like one day in one, like space and time, she existed here. And so yeah, like, yeah, in terms of doing things, like you can reach your goals no matter where you are from. That was one of the big thing for me, and I would like to say the same things for our students too. Like, don't be limited by, like, what are the resources around you or where you are born. Like, it doesn't matter. Like, always try to, like, go ahead, learn from the failures.
Thank you, dear Karishma. And I noticed like Turing, do you have any questions for that? I noticed that you have been already raising your hand. Yes, Turing, go ahead.
Sir, I don't have a question. I can show you. Robot.
Yes,
You have a
you
robot.
have a question? You have
I
a
don't.
comment?
I have a robot.
Oh, you have a robot. What your robot does? Oh, amazing! Did you build that robot?
Yes.
Oh, congratulations!
Thank
Thank.
you.
Thank
What
you.
does it do?
I. It actually can't move. Normally, I need
I see.
to
Okay, that's a good start. Like, as you grow up, you will make a robot that will move. But that's a fantastic start. Thank you for sharing.
thank. Thank you, madam.
Thank you.
Okay, Turing is one
Oh,
of
that was
our
amazing.
youngest one from this group.
Yeah. Mhm.
Because we have a huge range of the age, like
Yes,
starting
yes,
from 6 to like 20 to 30. It's something like a mix up.
that's
And dear
amazing.
student, yeah. And dear students, still you have any kind of questions, and make sure to raise your hand. And also, Karishma, while you are just studying to reach in your goals, so what are the barriers that you have been just faced?
So many. Uh, yeah, there were like, yeah, so many things, but I think the good thing was, I always had people around me. They wanted to, like, push me and like uplift me. So, like, one of the barriers was, when I got accepted for, like, masters in space science in France. uh, it was very emotional moment for the parents, that, like, how you gonna go by yourself, like, one of the classic questions for the parents. And they were kind of afraid of my journey, that how I would go and like do things by myself. But that's where like communication comes in. Like, like, I'm like, guys, you were the one who were supporting me throughout this, right? Like, you were the one, you were taking me to these, like, to these lectures, to feed my space curiosity. And now this is the moment. So that's where, and why I'm sharing this, because communication really matters. It could be either with your parents, with your teachers, or like anyone who you are negotiating for your, I don't know, like for your degree or like the future job. um, so that was the moment I had to, like, take them in the trust and communicate that, hey, like, I'm, like, now I'm grown up, I'm independent woman, and I can, like, I can take care of myself, and like, I will keep you updated, will be connected. So it took me a while, yeah, to talk to them and to convince them. That was one of the big barrier, like breaking the parents emotional heart. Yeah, and another thing, when I was getting accepted into NASA. This is like different sort of, but I'm sharing this because it's like one of the negotiation things that you need to have early on, and understand what you really want. Right. So in ISU in France, when I got like accepted to do internship at NASA Ames, um, in the beginning I rejected that, because I had, and I know people are like, what, who rejects NASA? But in the moment I had another opportunity with German Space Agency, DLR, and they were doing project in the space debris. And by the time I was very interested, like in like in doing like some sort of like robots for the space debris, and so that was the opportunity. So initially I said no to NASA, then I said yes to this space debris project, because it was like very like interesting project. And then after talking to friends, and then after my specifically my professor, they like they called me and they're like, Karishma, who rejects NASA? Like, this is a really good career point, like beginning for you. And he tried to understand the reason, and my reason was like, they didn't they weren't giving me the project I want, because there wasn't any robotic project when they proposed the projects for me, like the internship projects for me. And I was very clear that I want to go ahead with the like robotics mission. And when my mentor from NASA understood that, he proposed me a couple of projects which was actually robotic project. And one of the project was CubeSub, I just mentioned. And I'm like, oh, okay, Europa is way more interesting than space debris. So that was the thing that like I kind of negotiated my own project that I wanted. I want a robotic project. So, and why I'm saying this, because this is like, it's not exactly the barrier, but like it's kind of a thing you want to know early on what you really want, and how you talk to like people about that, how you negotiate your dreams. Because even if it's the small step, like that kind of set the rest of the like rest of the path for my career. So all the girls and the boys out there, I would say, like, always talk about your dreams and negotiate for your dreams.
That's quite inspiring. And also, like, I noticed that very huge key moment in your journey, like selecting the industry instead of the PhD. So, like, what is the reason?
Yes.
Like, it's a very big moment.
Yes. And yeah, and like I basically spent like 2 years in that journey, right? Like, I also wanted like specific department, not the university, because for PhD it matters like who's your professor and like what is the department, right? So that's why I spent time in Japan. I spent time in Stanford, which was like both of the professors were like amazing. Yeah, but yeah, at the end of Stanford, I went through the things, which was basically like I wanted to do, like the thing I wanted to do wasn't like deep fundamental research. Since like I'm engineer and I had like robotics background, I wanted to do more hands-on things. I'm like, hey, like I can build and I can do research on the go. You always learn things. So that has been the thing. Like the computer vision, I started at NASA Ames. I did not know anything about computer vision. My mentor pushed me into that. He, like he had, like many years of expertise in that. He gave me some of the Stanford curriculum to, like to understand more about it. So I was always like learning, like on the go. So once I recognized that I can do, like learn and apply. I'm like, if I can do that, why should I spend 5 years just doing research and publishing papers, whereas I can do the missions? Because I really like the hands-on things, and I was very mission oriented. And of course, that was for me. I wouldn't give this advice to anyone. As I always said, like, understand what you really want and always follow that. So I would say the same thing again. Like, if you want something that you can get out of PhD, feel free to go ahead, like do the PhD. But that's not what I wanted. So that's at the end of it, that's the decision I took, and like went back to the industry and like worked on few more drones.
Thank you, Reshma. And I noticed, sorry. Thank you, Karishma. And I noticed that Reshma have been just raising the
Mm-hmm.
hand. Yes, Reshma, go ahead.
Yeah, Reshma, please go ahead.
How would you feel if we finally like found out that life on extraterrestrial planets existed, and what do you think this could mean for like our future?
That's a really good question. I feel like there are many aspects, but the aspects I know is like finding a second form of life or the life form that we don't know about. It's like finding the second genesis for the life, and with that, I think we will just understand more about how the life in the solar system, like has been formed, right? And the way we know here is the carbon-based, like carbon-based life here on the Earth. So if you find something, like people talk about like bunch of other stuff, other life forms, like this talks about like silicon-based life forms and like, yeah, lots of other stuff. But like having that would mean that there are some other ingredients that exist in the space that can also make the different life form. And one of the other thing, talking about life form, there are theories that even like probably like we might have come from Mars. We don't know that where we have come from yet. So understanding like when we are going to Mars and like drilling, like more deeper with like Mars 2020, we try to do that. It's basically to understand, like in the quest of understanding if we existed there or like where we come from. So there are many like philosophical and scientific questions we will be answering with that.
Okay, thank you.
Okay, dear students, if you have any further questions, make sure to raise your hand. Otherwise, like you can send a direct email to the our dear guest speaker, Karishma, and I will just provide you some emails and some other links. Also, that a new startup, space next generations. I think like hope like in the future, like you also can collaborate with something like worldwide. So, dear student, with that being said, like I'm going to wind up the today's sessions, and before that, I want to just pass our appreciations and the greetings to the dear Karishma, and providing such a valuable insights and the talk, and that would be really inspiring all the young generation as you wish. And thank you very much, Karishma, taking our invitations and quickly schedule the time and having a very interesting talk. And we will wishing you very all the best for your future activities and endeavors. Thank you very much.
Thank you so much for being here and like yeah, taking your time to understand more about space robotics. And thank you, Aravind, to like to give me this opportunity. And yeah, I would love to collaborate in future in as I go ahead on my journey. And all the best for all of your endeavors. Like you're doing a really good job, inspiring the next space generation of
Yeah.
Sri Lanka.
Yeah. Thank you, Rishma. And dear students, we will see you at the next Saturday in the evening from the Sri Lankan time, 6:30 p.m. onwards. See you at the weekends.